Every sewing machine collector's worst nightmare is receiving a rare machine only to discover it's missing its shuttle. This happened to us with our 1871 Little Wanzer sewing machine, which takes a very small shuttle that's unique to it. Replacement simply can't be found. The only alternative is to make one. From pictures obtained online, we learned Little Wanzer shuttles look like this. From this picture, we got the basic configuration. The size of the shuttle carriage provided the shuttle's outside dimension, while the bobbin winder did the same for the bobbin, which told us how long the inner chamber had to be. The shuttle needs to be 1 3/4 inches long, 7/16 wide and tall, and the bobbin chamber is 1 inch long. It should look like a smaller version of this boat shuttle. We started by buying a piece of 7/16 bar stock. If you're willing to spend a little more time on rough grinding, any piece of steel will do, such as the old crowbar I used for my first attempt. Next, I drew the basic outline and then marked where all the holes that I'm going to be drilling need to be drilled. These have to be scribed because some of the dimensions are very precise and we don't want the bit drifting as we start to drill. So, let's get started.
Drilling out most of the bobbin chamber saves a lot of time, but does require a drill press. Be sure to use lots of cutting oil and clamps. If you have one, a milling machine would work much better.
And there we go. The holes not only remove the bulk of the material needed to accommodate the bobbin, they also act as depth guides. As long as they don't grind any deeper, I never have to worry about grinding through the bottom of the shuttle. Leaving the shuttle attached to the bar stock as long as possible makes work on such a small piece much easier. The point of the shuttle is offset about 1/3 from the bottom and 2/3 from the top. This allows it to pick up the thread a little easier when it's in the shuttle carriage. I've tried many tools to finish hollowing out the shuttle, and I found what works the best is a Dremel tool with a cutoff wheel. Let's get going. Okay, I switched to a fine grinding tool to clean up some of the corners that the cutoff wheels couldn't reach. So let's start shaping the outside.
Again, using a cutoff wheel works great for rough shaping. If you have one, a belt sander also works good.
All right, there's the upper profile. The reason I cut such big reliefs here is that the polishing tools we're going to use after we're done with the Dremel need some room to get around these corners. Now let's turn it on its side and start on the sideways profile. All right, that's looking pretty good. Now here you can see the holes I already drilled into the side. I didn't show that step, but these are 1/32 inch diameter holes. These are the tensioning system. You loop the thread after it comes off the bobbin in and out of these holes until you get the right tension. Next we start smoothing these edges and create the final shape. Alright, that's starting to look like a shuttle. For final shaping and preliminary polishing, I switched to a flap wheel on the Dremel tool. I find that this works better than any of the other grinding bits or polishing bits that I found. Next, we go to the 400 sandpaper, then 600, then we'll start on micro meshes, and pretty soon this is going to have a mirror finish on it. An important tool for shaping the outside is one of these feeler gauges. The jaws in the front feel around on the inside, and the spacer in the back here tells you how much metal you have left. This is important so that you know you don't grind so much on the outside down that you grind through to the inside. All right, and there we go. A mirror finish over almost the entire surface. The most important area to get polished as good as possible is the very tip. This is where the loop has the greatest resistance to sliding down the shuttle, so you want this really smooth so that it doesn't hang up. All we have to do now is cut off the base, polish it, and then add some of the hardware on the inside to hold the bobbin, and we're done. And here's how it turned out. Slippery little devil. Okay, for the long bobbin, I took a regular long bobbin, which are easy to find and inexpensive, and I had to cut it down about 1/4 of an inch to fit inside this small shuttle. I also had to reduce the diameter of the end caps to fit inside the narrowness of it. For the center caps on which the bobbin rotates, I epoxied a piece of brass to the end here after I punched a dimple in it to hold the point of the bobbin. And on this end, I did the same thing, except instead of epoxying it, I used some foam mounting tape. It gave enough springiness to hold it in place and yet let it be removed. Now, in real bobbins, they machine in a channel and use a spring system to provide that tension, but I don't have the machining necessary to make such a complicated structure. Anyways, it came out pretty good, so let's put it in the machine and see if it works. Let's see if it fits. Perfect.
The stitch is tight and clean, so I count this as a success. Altogether, it took 6 hours to make this shuttle and bobbin, which is a pretty good deal considering it turns the Wanzer from being an odd-looking paperweight into a working sewing machine. I hope you found this video helpful if you need to make a boat shuttle for yourself. Thank you for watching, and as always, please check out my main website at waynesthisthandthat.com.